So in the last video we talked about the production possibilities frontier, which shows the limits of what a society or an individual can produce given their current resources and technology. And we talked about a couple of ways to shift that, and that is by increasing the available or improving the available technology or resources. One other way that one can get beyond the production possibilities is through specialization and trade. And this is kind of good news for people who may feel stuck with their current possibilities. So maybe you can't afford increases in resources or technology, but you're stuck there, right? The good news is there are other ways to move beyond your personal production possibilities, and namely that is to work with others, to specialize and to trade. So specialization means that you're limiting your work to a particular area. You find something you're good at and you do it, and you go all in. So for example, Steph Curry, who is pictured here, he has found something he's good at, and that's what he does, right? He spends most of his days practicing that one thing, getting especially really good at it, and doing that one thing. That's specialization, limiting your work to a particular area. So for our model, as we talk about and think about specialization and trade, we're going to have a few assumptions. Specifically, we're going to assume ceteris paribus. So we're going to assume technology is fixed. We're going to assume the quantity and quality of resources are fixed. We're going to assume society produces only two goods. So these are the same assumptions that we had when we talked about our production possibilities frontier in the previous video. We're going to add one more to that. Now we're going to say we've got two people that have different abilities in the production of the two goods. So we're not talking about a society or an individual now. We're talking about two people who can produce two goods, and they have different abilities in production of those two goods. And when we think about an individual's ability to produce a good, or two individuals compared with one another, we think about a couple of different types of advantage. So absolute advantage means one producer can make more than the other producer with the same quantity of resources. You're just better at it than the other guy, right? Comparative advantage, on the other hand, means you can make a good at a lower opportunity cost than another producer. And there's a slight difference here, and we'll see when we get to an example in a second how that works out. The differences in producers' ability to produce goods allows them to specialize. And when you specialize, this whole thing works out the best if you specialize in what you have a comparative advantage in and you trade for the other goods, right? So we're going to figure out who can produce a particular good at a lower cost than the other person. Who has the comparative advantage in producing this good? And that's the person we're going to assign to producing that good. That person's going to specialize in producing that good. So let's look at an example. So we've got two folks, Gwen and Blake, who make pizzas and wings. And the way to read this chart here is with a big or in the middle, right? So this says that Gwen can produce 60 pizzas or 120 wings in a day. So these are the limits of her production possibilities frontier. We'll see on the next slide a picture of the production possibilities frontier, and these two numbers will form the intercepts of where her possibilities frontier will cross the two axes. So if she devotes all of her time to pizzas, she makes 60. If she devotes all of her time to wings, she makes 120, or she could make some combination in between. And similarly for Blake. So looking at this chart, answer for yourself, who has the absolute advantage on pizzas? Who has the absolute advantage on wings? And the answer to both of those is Gwen. Gwen has the absolute advantage on both. Given one day, she can produce more pizzas than Blake can in the same day. Given one day, she can produce more wings than Blake can in the same day. Gwen is just better at producing both pizza and wings. She has the absolute advantage in both. So should she produce both? The answer is no. If we're going to specialize and trade, we need to assign one thing to Gwen and one thing to Blake. And it turns out, as we'll see in this example as it progresses, that the way to do that is to think about, instead of absolute advantage, think about comparative advantage. So who has the comparative advantage on pizzas? And who has the comparative advantage on wings? How do we figure that out? So remember, comparative advantage is the ability to produce a good at a lower opportunity cost than the other person. So for Gwen, if you think back to that table, for Gwen, 60 pizzas is the same as equivalent to 120 wings, right? In terms of the amount of time it takes, the amount of resources it takes to make them. So for Gwen, 60 pizzas equals 120 wings. And for Blake, 24 pizzas equals 72 wings. Right? So for Gwen, the opportunity cost of making one pizza, right? So opportunity cost. One pizza is how many wings? How do we figure this out? Remember from the last video, what we do is we just do a little algebra here. If 60 pizzas is 120 wings, we can divide both sides by 60, and we find out that one pizza is 2 wings. 120 divided by 60. Right? And for Blake, one pizza is, divide both sides by 24, 3 wings. So who has the comparative advantage in making pizza? If Gwen wants to make one pizza, she has to give up 2 wings. If Blake wants to make one pizza, he has to give up 3 wings. Clearly, Gwen gives up fewer wings to make pizza. Gwen has the comparative advantage in pizza. Right? She only has to give up 2 wings, when Blake has to give up 3. What about wings, though? So again, for Gwen, 60 pizzas is 120 wings, which means one wing is how many pizzas? Divide both sides by 120, because our goal, again, is to make this a 1 over here next to the W, right? So divide both sides by 120, and we get that one wing is 1/3 of a pizza. Excuse me, no, 1/2 of a pizza, sorry. So 60 over 120 is 1/2. You can use your calculator. And for Blake, we have 24P equals 72W. We want to figure out what is 1W, so we divide both sides by 72 to get the 1 over here, and we get 1/3 pizza. So, if you struggle with fractions and it's not clear to you, think through it or ask your calculator. 1/3 is smaller than 1/2. For Blake, a wing costs less than for Gwen. If Gwen wants to make one wing, she has to give up half a pizza to do it. If Blake wants to make one wing, he only gives up 1/3 of a pizza to do it. So, Blake can make wings at a lower cost than Gwen can. Blake has the comparative advantage in wings. Here's the deal. You'll notice a couple of patterns, a couple of things here. One is that this is always the reciprocal of that, right? So once you've figured out one of them, you just take the reciprocal, or you can always go through the math again. So this is 2, this is 1/2, this is 3, this is 1/3. It's also true, unlike with the absolute advantage, where Gwen had absolute advantage in both pizza making and in wing making, you would never, as long as you've got two people with different abilities, it's always the case that if one of them has comparative advantage in one good, the other has the comparative advantage in the other good. So Blake may seem like he's not good for very much if you look just at those raw numbers and look only at the absolute advantage. But the truth is, when you think about the opportunity cost of production, rather than just who can produce more, there's always one thing that Blake is better at in terms of comparative advantage. And in this case, Gwen has the comparative advantage in pizza, and Blake has the comparative advantage in wings. So what that means is, when we get ready to specialize, Gwen should make the pizza, Blake should make the wings. So here are their production possibility frontiers. Notice, as I said, that our that the axes cross at their limits, right? So if she devotes all of her time to pizza, she makes 60. If she devotes all of her time to wings, she makes 120, and he 24 and 72. All right. So just for simplicity's sake, for this example, let's think about them selling combinations of pizza and wings. Right? So if they do that, the best that Gwen can do on her own is sell a combination of 40 and 40. And the best that Blake can do on his own is sell a combination of 18 and 18. They cannot get beyond their own production possibilities frontiers. They're stuck with their production possibilities if they stick to it on their own. So if they do not trade, then their production and their consumption are the same, right? And in this case, we're using the word consumption in an economic sense, meaning the amount that you use, right? So it doesn't necessarily mean you're consuming as in eating the things. It could mean that you're selling them and then using the money you get from them. But the point here is that if we don't allow any trade, if Gwen and Blake don't know that each other exist, or they know but they refuse to work with each other, then what they produce, for Gwen it's 40 and 40, for Blake it's 18 and 18, is what they consume. 40 and 40, 18 and 18. And that's the best they can do, unless we allow them to specialize and trade. So if we allow them to specialize, remember we go back to our comparative advantage discussion, and we say to Gwen, you have the comparative advantage in pizza. You can produce pizza at the lowest opportunity cost, so you do that. And we say to Blake, you produce wings at the lowest opportunity cost, so you do that. And so we tell Gwen, spend all day on pizza, so she does, and she makes 60 of them. We tell Blake, spend all day on wings, so he does, and he makes 72 of them. Then we let them come together and trade. And this is just an example of a possible trade between the two of them. But if we let them trade, say Blake keeps 25 of those wings that he made, and he gives the other 47 to Gwen. Right? So at the end of the day, Gwen has 47 wings, Blake has 25. And Gwen keeps 41 of her pizzas and gives the other 19 to Blake. So at the end of the day, Gwen has 41 pizzas, Blake has 19 pizzas. What's the result? The result is that with specialization and trade, each person consumes more than they could otherwise. We have moved both Gwen and Blake to a point outside their previous production possibilities. Not by increasing their own resources or technology, but just by allowing them to specialize and trade with others. This is good news. If you can't afford new technology, you can't afford to send your cooks to school or whatever, all you got to do is find a buddy, pair up, or even better, find 5 or 6 buddies and do an even better job. But so find a buddy, specialize, trade. This is another way to get beyond your production possibilities without having to have any changes in technology. So when we designed the trade that we looked at a couple of slides ago, remember Gwen made pizzas and she gave 19 of them to Blake. Blake made wings and he gave 47 of them to Gwen. How did we know that would work? How did we know they'd both be willing to make that trade after they specialized? The answer comes in looking at those terms of trade and how they compare to what Gwen and Blake could have done on their own. So the terms of trade are the relative prices or exchange rate of the goods. So if we express that as a ratio, pizza to wings, and it really doesn't matter here, by the way, you could do wings to pizza if you wanted. There's no magic in putting pizza first. You just want to be sure you're consistent. If you put pizza first, you want to put pizza first all the way down the board. If you put wings first, you want to put wings first all the way down the board. So if we think about the ratio of pizza to wings for Gwen and for Blake, right? When they're on their own, what's the best they can do? For Gwen, if we look up here, we already did the math, it's 1 pizza to 2 wings. So 1 to 2. And for Blake, it's 1 pizza to 3 wings. And again, if you did this wings to pizza, you'd just have 2, then 1, or 3, then 1, right? So you just want to make sure you keep the same one first every time as you go down. It doesn't matter which one you put first. So the best you can do if you don't specialize is a trade ratio. And again, if you're not specializing, it's kind of funny to think about, but that trade is with yourself, right? So you're trading yourself in terms of your time and resources it takes you to make one thing versus another. If you want 1 pizza, you have to trade 2 wings for it, though you're trading with yourself, right? But the best Gwen can do on her own is a trade ratio of 1 to 2, or 1/2, or 0.5, right? The best Blake can do on his own is a trade ratio of 1 to 3, or 1/3, or 0.33. So, if we go back to our exchange here, if we think about the proposed trade, right? So Gwen comes to the market with her 60 pizzas and she meets Blake and she says, I've got 60 pizzas and I'm willing to give you 19 of them if you'll give me 47 wings. So the trade ratio that's being offered here is 19 pizzas to 47 wings, right? 19 to 47. Now, this is when you pull out your calculator and you do this math. So what did we do to get 0.5 here? We said we turned the little colon in the middle into a fraction bar. 1 divided by 2 is 0.5. 1 divided by 3 is 0.33. What is it here? 19 divided by 47. Ask your calculator. I think your calculator will tell you the answer is 0.4. Now, what's significant about that 0.4? It's between 0.5 and 0.33. And that is how we knew that this was a good trade. It's a good trade for Gwen because it's better than she could do on her own. It's a good trade for Blake because it's better than he could do on his own. Now, the closer this number gets to 0.5, the better it is for Blake. The closer this number gets to 0.33, the better it is for Gwen. So, for example, if Gwen comes to the market and she says, I'll give you 19 pizzas if you'll give me 48 wings, right? She's asking for a trade that's a little better for herself. Now, you'd have to do the math and figure out whether Blake's going to say yes or no to that, right? Is that good or bad for Blake? It'll certainly be worse for Blake than 19 to 47, but it still could be better for Blake than he could have done on his own, right? And where exactly we end up between the 0.5 and the 0.33 kind of depends on some other factors, maybe some psychology or some bargaining power, maybe maybe Gwen says, well, I have the absolute advantage in everything. I don't have to trade with you at all, or something like that, And so she's able to sort of pull that number a little better for herself. But where we end up in between is sort of a matter of other influences. But the point here being, as long as this terms of trade is between those two numbers, it's good for both. Perhaps it could be a little better for Gwen, or perhaps it could be a little better for Blake, but it's better already than you could have done on your own. That's the point. That as long as that terms of trade gives us a ratio that's between what they could do on their own, that's better than Gwen could do on her own and better than Blake could do on his own, then it's a good trade, or a trade that works out for everyone. So in this case, the terms of trade of 19 for 47 gave us a ratio that was in between, that benefits both sides. So lastly, just tying all this up, a lot of times we think about specialization and trade in a macro sense, and we think about it occurring between countries, but it's important to remember that it has a lot of implications in a micro sense as well. It can occur on a much smaller level. It can occur between individuals. It can occur between individual food trucks or individual firms. It happens within a home when you say, you cook, I'll clean. That's specialization in trade. Happens at a gathering of friends and family. When you come, it's a potluck meal. That's specialization in trade. I cracked open the green beans, and I really hope someone else took the time to cook the mac and cheese, right? Specialization in trade happens all around us, and when it does, the point of this exercise has been to show that everyone benefits